It'd be useful if I start the recording. So we're talking about entities right now. And the idea, again, I need to re-say this with a recording, is that it's basically a base gameplay unit. So our world is the world is an entity to a certain extent. Within Unreal, that gets broken down into all the different actor meshes and actor components. I just put it right there. The player is an entity, whereas the player model that they're using, again, we're talking in a multiplayer standpoint from these engines. The weapon that they're using is an entity. Any pickups, armor, health, anything that needs to move doors, for example. So automated doors, elevators, whatnot, jump pads, other level elements are entities. And think in an Unreal, they are defined, there's a class that defines it. Now, particularly with Unreal, we're going to talk specifically about Blueprint in C++. We're going to leave Verse to the side because it's the Fortnite system. And it's a scripting system for Fortnite. As I've told in the past, when we go back to Unreal Engine 3 and earlier, there used to be Unreal Script, which was this intermediate layer between the level stuff where Blueprint comes from and the native C++ code. With the advent of Unreal Engine 4 and now into 5, so Unreal Engine 3 had a system called Kismet, and that is where it was a level design system. And that grew in stature and scope to what we know now known as Blueprint today. And so one of the things that happened between 3 to 4 was that intermediate layer of Unreal Script got stripped out. And there were a lot of good reasons why to strip it out. But basically, the barrier between Blueprint and the native code, there was an overlap. And that overlap has grown over time, effectively. So you can build a whole game using Blueprint. You can build a whole game using C++. You don't want to. As you get into another course, you'll learn the C++ side, but the very high-end games are using a combination of both. Epic is using a combination of both. Fortnite, Unreal Tournament, particularly community. One of the things they would talk about in the community version of Unreal Tournament was that if you were building a weapon, some of the base level of that weapon needs to be done in C++. There should be C++ implementation for that weapon. But effectively, think of Blueprint as taking these generic and the goal is that you'll take that where you'll eventually go is you'll build these generic C++ classes, which are then finished by specific Blueprint classes. So today, let me bring up your lab. And so today we're going to look at what's called the level blueprint. And this is our first go at playing around with Blueprint. Now, the level blueprint is specific to the level you are in. And this is a holdover from Kismet, to be quite honest. It's useful in very specific things. The problem is that you do something in the level blueprint, you go to a new level, you have to rebuild it all from scratch. We are going to do something one way this week in the level blueprint, and next week we are going to look at Blueprint classes and rebuild a good portion of what we're going to. This assignment we're going to do again with a Blueprint class instead. But right now, I need to get you this familiar with. Hey, this is the basics of dealing with Blueprint in a general way, and this is how the level designers are going to work in some cases with the Blueprint. There'll be things that they need to do level specific. They'll be in the level Blueprint class doing stuff like this. So, you have a quiz. And basically, we're doing what I refer to as hello world in 3D space. We'll turn on a light on and off using a trigger. So, the term in Unreal is a volume. So you'll hear me say trigger and volume. In other engines, we'll call it a trigger. Epic specifically says they use a generic term called volume, which then have other applicable features. So, you have a quiz. Provide a diagram showing gameplay framework. Sorry, Unreal's gameplay framework, core classes, and their relationships. Each class must be nearly named, inheritance shown. You can omit the actor class from this diagram. The actor class is not considered. It's considered fundamental to the engine, but it's not part of the gameplay framework. In fact, all of these are going to inherit from actor, so that's why don't worry about actor. But I'll tell you, pawn is a class in this system that inherits from actor. You can create this image using a system. There's an online tool called Draw.io. It's a wonderful, if you're looking to do diagrams. Hooray, you can do diagrams here. You can draw this out. So, I'm going to go back. And you can use image from Unreal's documentation. There's an image, there's images, and there's more than one version of this image now. But there is an image for Unreal's documentation that if you look hard enough, you will find it, and you can just submit that as your answer, and you'll be right. So you can create this by yourself, but there's an image out there that's floating out there that I will accept as an answer because it's correct, and Epic is provided it for you. These are the PowerPoint slides. We'll go over those in 1 second. So here's our lab, here's our quiz. So I'm going over what you need to do this week to show you, here's where we're gonna go this week. This is the destination we're going to reach this week. And then I'm gonna show you how you're gonna get there. So that's what we're doing. They've got several. I've got several documents about blueprint introduction, overview. There's one for the gameplay overview, creating functions, and variables. So we'll talk about these in a little bit. What I've got. I got more PowerPoint slides to go over with you. Okay. Let's talk about. Let's go over the three. So in Unreal, your entities, the things you're working, there's a class associated with them. When you put something in the level, there's a class associated with it. Now, Unreal Engine uses object inheritance. So we talk about there is an Unreal object, and actor actually inherits off of that. A lot of the frame play thing, again, they technically inherit off of actor. Pawn being one of them, the player controller being another one of them. So while we are talking about specific classes right here, in practice, you are going to use a child of these classes. You're not going to actually use the player. There's a few cases where you'll use, but in a generic way. But when you're actually applying something to the engine, to do something with the engine, you'll be using a child of several of these classes. And again, the gameplay framework is a collection of C++ and Blueprint classes. So these are, they're all, again, as being these are core classes. There's a C++ core version of these classes, but again, they'll be very quickly. You'll see that there's you can grab a C++ and make a Blueprint version of it. And we'll actually go over when we go back into the project. I'll actually point out specific Blueprint versions of classes that are important for your purpose. So, Blueprint classes manage the rules of your game, player input, defines avatars, camera, player HUDs. I know it says UE4. Let me fix that. Oh, I got to go back and change the slides. They're talking about UE4. It's same in UE5. When you see references to UE4, just think of it as an earlier version of the UE5. Like UE5 is an upgraded version of UE4. It's not a massive jump. It's really UE4 underneath the hood, but upgraded. It's less of a jump basically going from Unreal Engine 1 to Unreal 2 was a big jump. Going from 2 to 3 was a big jump. Going 3 to 4 was a big jump. Going from 4 to 5 is not a big jump. Think of Unreal Engine 5 as a massively upgraded version of Unreal Engine 4. That it's really more, it's more marketing than it is an actual engine jump, really underneath the hood. So everything you see about UE4, with a few exceptions of things that have been replaced, like the terrain system has been replaced, and there's a new particle system that UE5 has, and there's a new light system that UE5. So there's a couple new things, but for the most part, the core of the engine has not changed. Again, you'll be able to, we're going to go familiar with the gameplay framework, learn between the game mode and game instance, learn about the pawn, HUD, player, get several states. Let's move on. So, this is not the image I want you to use. Don't give me this as your image, because it's not showing the relationships between classes well. All right, so there are several core classes. The two big ones right now that they're addressing is there is a game mode class, and this is the command and control class for your game. Think of any major game rules, major application things are going to be in your game mode. Game instance is a subclass that basically it's holding. Think of it as a data holding class. And there'll be a lot of game instance when you see state. So player state, game state. In this case, game instance. Think of it as at the application, the game, the instance of the game. So what might be in the game instance class? Well, your username, your Steam ID, settings for your mouse would probably get put in the game instance class. Because they're related to you. You will see in a single player game. So there's two terms. So there's network games and there are standalone. So the Unreal Engine can be in multiple network scenarios. I'm going to leave those to the side because that's not relevant. But you'll hear a term called standalone. And when you're in a standalone, basically think single player game. If you're just purely standalone, you're a single player game. And you're not connecting out of the internet whatsoever. So we're going to do things with the game mode, but later on you will learn that that's not the way to do it if you're working in multiplayer, and there's a whole class just devoted to that. And that's one of the things that that class right now is about to hit their heads on really hard. So if you see multiple dents in the wall, it's probably them hitting that wall really quickly.
Oh, that's what it is.
So game instance is related in that regards. We have the pawn class. So this is, think of what you control as a player. So you're my player model in a first-person shooter. The vehicle that I'm driving around in a driving type simulation. Anything that you as a player can control will somehow inherit from the pawn class. We're going to skip HUD for one second. HUD basically is anything that's going to go on the screen. Basically, HUD class is going to manage what is being shown on the screen. Think of the HUD. So and when we will talk more about the HUD and how to build HUD pieces later on. But that's related to the player controller class. The player controller actually owns the HUD class because it's specific. Again, each player controller. So you have a player controller on the. So when we think of the player controller, think of it as a class that represents you, the player. It grabs input. That's the big piece. It grabs the input and manages input, and also and passes that input from you to the model that you're using. So the first relationship that you have is that the player controller can take control of pawn classes, and that's how input gets from the controller or the keyboard and mouse, or whatever input system you're using, to whatever's in game, you're controlling in game. We've got 2 state classes. Again, we've got a game state class, so the game mode has, there will be things that it's either game instance or it be in the game state class. Like the current game score would be in the game state class. Time remaining in the round would be in the game state class. And that's so that you can push that out to all the clients. And again, that networking issue. Player state class, another one is that you only have the information, as a player controller, you have your information, but you don't have other player controllers to muck around and touch. So their information that's relevant to you will be given to you in the player state class. Networking piece, so don't worry, we're not going to worry too much about. We'll be doing a lot of things in the player controller or the pawn class or the game mode classes right now in this class. But later on, these are other classes you will get to. Just went over. Let me move this over. Here we go. So game mode is a good place to script respawn systems for a first-person shooter or a timer for a race game. I've gone over several of these classes right now. One of the things that you'll see is that in the game mode there is a classes section, and that will determine what core classes are related to the game mode that you're working with. So a lot of time, the big one that we will be, the player controller class right now is going to be the big one that you're going to be adjusting. So there'll be a lot of times where we will go and I will say, hey, make a copy of this class, and go over and make a copy of this class, and then adjust it. But you'll need to set that version of the player controller on. Sorry, not player controller. It'd be the default pawn class. Sorry. So we'll make a variant. So sorry, my apologies. We will make a variant of the pawn, the base pawn, and then do things with it for this lab assignment. And that's something that I'm going to make sure that's very clear in this. Wasn't so clear in previous versions of this version So if you look at older lectures, I go right into the base pawn class and we start working right away. We're not going to do that this term. We're going to make copies of that. We're going to keep that base pawn class. And let me point that out right now, what we're talking about. So if we go to our content draw for the template, let me go to the content draw. So here is the level 1 that we did this week. Literally, do yourself a favor, make a new folder. Just call it Lab 02. I mean, if you really want to, you could, in theory, I mean, you could go make a new folder. This is game 1303, and drop them into there. Move here. Yes. We're moving a level, that's why. Okay, let's go back. Why did it move the... Okay, I can delete this now. There we go. Delete. All right. So again, now I have a folder for all the classwork in this class at this point. And here we go, Lab 01, Lab 02. And these will build into stuff as well. Let's go grab... No, I'm going to grab this level, and I'm going to just save the current level as, go into the Lab 02 folder, and I'll just call this Lab 02. And that'll make my life easier. Again, we'll use copies of things. The big one, again, I'm going to go back to the content draw. There is a folder for third person. Now, there are some variants here. Don't worry about them. We'll talk about them later on. But there is a blueprint folder here. So there is a blueprint third-person character. There is a third-person game mode, and a third-person player controller. I'm not sure what the player controller's got in it. Let's take a look. Data only blueprint, open blueprint. I don't think they did anything. I think they just made a blueprint version of the player controller. So there is the parent class. So you'll see Mug. So the name of the project is Mug _ F25. So basically we had the template renames files with the template with the name of the project you created. So this is the player controller that's specific to the template, and we have you guys pay attention to the projector, please. I'm pointing out things to you guys. So if you wanted to see, hey, what does this blueprint class inherit from? Who's its parent? It's right here. So this is part of the inheritance chain for player controller. So one of the things I want you to be aware about is that when you're dealing with inheritance, if something inherits from another class, it is technically an instance of that class as well. It can be considered an instance of that class. What's up?
What is the number after
F25.
Okay.
Yeah, this year. Yeah, I basically, so if you remember the name of the project, it was Mug _ F25. That's where that comes from. So whatever you call your project, you'll get a bunch of base classes that will be something, your project name, player controller, something pawn, something game mode. In this case, we have a blueprint version. So the blueprint here is basically inherits from that, and this inherits from, and we actually can click on that and we'll bring up Visual Studio. And if you give it a sec to get Visual Studio. So .h is where things are defined. I'm just going to close things. And you can see right here, here's the class right here. We'll talk about, but you can see that there's an A. It means it's an actor. But here is Mug F25 player controller inherits from a player controller. The A in front of something is just a class nomination, basically saying it's an actor class. You will see U and F are the other two terms you'll see. So this is if you jump into C++ code. If you see like a vector, you'll see F vector. F rotator. Rotations are in a rotation class. The other one is U. So things that are components would typically end up being a U. U static mesh, for example. So just technology debt. This is from like Unreal Engine 1 naming conventions we're dealing with here. So close Visual Studio. You're not going to use Visual Studio. If you happen to click this and you open up Visual Studio, just close it. Don't worry. All right, so let's close this one. There's nothing actually in there. These are the two that are important right now. So this player controller has, let me just move this up here. Again, this section of classes, again, has got, here is the player controller set here, and they've got the third person character set down here. So this is what you'll be setting in that class. Particularly, this is the things that you'll be setting. If we open up the full blueprint editor, you'll get what's called the event graph, and this is blueprint scripting for this object. There'll be other graphs, but the big one is the event graph. For our purposes, so this is in a blueprint class. For our purposes, let me go over one more, last one. Here's the third person character. So viewport, this is how the object is constructed with the things that you can see. So basically the big one is an arrow, there's a mesh, capsule component is collision, and then there's a camera boon, and then there's the follow camera set. So this object has a camera setup within itself. One of the things you will see is that typically the player controller, either the player controller or the pawn will have a camera setup with it. So you'll see typically there's a camera manager class that's typically attached to the player controller, but you'll see that as we move more from early UE4 to UE5, the camera gets put more with the pawn. So there's a camera connected to the pawn that you're using. So Just giving you ideas here. So here's the player controller. So let's say for our purposes, I want to do something with this third-person character. There's two things I can do. I can right-click on it. I can create a child blueprint class. So I can make another class that inherits off of this. The other one that I can do is I'm actually going to open up this folder. I'm going to grab it and move or go to a folder here. And I can either move it here, copy it, or do an advanced copy here. And I'm just going to do a copy. This is if you were doing a whole folder, you do an advanced copy. But I just need to do a single object. I'm just going to do that here. And now I've got in here, I've got now this BP third-person character. I'm just going to rename it to. So you'll see blueprint classes have BP in front of it. BP Lab O2 pawn. And hooray, I have now added this pawn. One of the things that you can do is that we can set things up by the level itself. So there's the game mode information. One of the things, so right here in the level right now, I've got a world settings panel open. And if we go to Windows, that's down here. So world settings, basically the big thing here is that, hey, there's this game mode section right here, and there's a game mode override. So this is what game mode should this level load by default. And for our purposes right now, it's the BP third-person game mode. So it's a game mode class. We can open up the selected game mode, and we can see things that we can override here. In fact, I'm actually going to go in, and for our purposes, for the default pawn class, I'm actually going to assign, and I can just click and drag objects, So this is a template. This is, think of this as an entity. I've just now assigned the BP02 pawn to the level. So when I spawn into the world, it's going to use this version of the class. And we'll just show that how this will work. And there's a lot of stuff in play right here. There's a lot of stuff here. I got to take a look at what they've done. Touch input. So they've had an event processed here that I gotta go look at in more detail because it's changed. But for our purpose right now, there's an event that I want to use. It's called begin play. And when the level starts, the level is loaded. This gets kicked off. And I'm just gonna go and use what's called print, and it's gonna take a string. Now, I could there could be something, a string that I could be a variable that I could apply here, or I can go in and hard code something here. So I'll do hello world. You will compile, and when I go back to level right now, you will see that there's hello world. Now hello world's rather boring. And this game has inheritance from deathmatch games, so let's do some little bit of trash talk. And again, I'm being facetious right now. This is and you can see now that is now when the level starts, begin play. So this is when, and you will use begin play to set up things and initialize things on objects when they enter the world. There'll be things that are specific, that are relative. Like if you needed to know where it is in the world where it started, where you placed it, that would be on begin play. In fact, let's do that actually right now. Oh, and I need to stop simulating things. And we will take this out for our purposes right now. So there are nodes all over the place with Unreal. One of the things is that with your, let's go back to the character. There is a transform component. So there are component there. So Unreal builds their objects based on different components and different things. This object has, so you will always have a transform, and that represents its location, rotation, and scale. And we can actually ask the actor's location that way. Now you can ask by component. We can also ask by, so for our event graph, one of the things you'll do is you'll select something like the capsule component. Let's go to event. We can go and we can create, we can add an event. We can call a function on the capsule component. And again, and with that selected, things will can be context sensitive. So the component. So get world. So because we have the capsule component selected, it has a get world location based on the capsule component. There's also get relative transform or relative. Well, we can get the relative transform. And so this is getting the relative. So this is the object relative to the root of the object. So again, this is the, let me see, make it a little bit bigger so you can see it. So here is, I believe this is the root. Yeah, so the capsule component here is considered the root of the object. So what we will get is its world location. But if we ask for the mesh, we could then move the mesh, like make adjustments to the mesh relative to its origin in the world. So I'm showing off relative and local, and the other term you'll hear is local versus world location. One of the things that you'll learn is that there are multiple coordinate systems. The world is a coordinate system. Your blueprint is located somewhere in the world, but internal to that blueprint, there's objects that the blueprint contains, and they are relative to its origin. So if I've got an object that's 1 unit high, well, it'd be 100 units high. It would be effectively or Unreal, or 1,000 units high. If I move that into XYZ somewhere in the world, it'll be XYZ plus the Z will be 100 units effectively in the world grid for that object, that mesh piece. So we can also, so the transform is a value that contains other values. Vector is another one. So a vector contains 3, for our purposes, will generally contain 3 values, the X, Y, Z. You can right click on here and split the struct pin. So structs is the term for a value type that contains other values. They're not full-on objects, but they work kind of like objects. But not quite. We can split the struct pin. You can see right here. Here is the value location, and it's of type vector. We can actually even break this again even to more, and now we can get to the floats, X, Y, Z, and there's a rotation here which we can split, and a scale which you can split. We can also right-click and we can recombine the struct pin if we want to. So we can ask, hey. I deleted the begin play. That's interesting. So I'm going to recreate begin. So I've shown you how to get the component. There is also the actor location. So we'll get the actor location in this case. Again, target self means the object that it's on. So this is all this code is relative to the instance of the object that we're talking about. So we're dealing with the third. Oh, I'm in the wrong class. That's why. Hold on. I can cut these. I'm going to close this and I'm going to go back to, here we go. Went to the wrong class. There we go. I'm going to only use the actor location, but in this case, I'm going to use what's append. There's different versions, so append string is what I want. And this is going to be useful. I can plug this in so the output of this module will result here. I'm going to put the return value here, and it's going to basically take the value and use. There's a common function method depending on how you call it. It's called toString, and this is basically formatting the vector to a string value for me here. And then right here, I'm just going to say location, player start location. And now when I print this out, I'm going to compile. I'll save everything. And that's you'll see me use Control-Shift-S to save everything. And when I press play, you'll see that now I have a start location of X. Again, it didn't stay long enough. We can open this up, and we can change this duration. We'll do this 5 seconds. I'll do text color of red so it can be seen. And again, you can print to the screen, print to the log. So there's more options here. And I will compile. And you can see right now that player start 000, and I was like 300 up where I started. So when I talk about the log, scroll all the way down here. This is not the log I was thinking of. Oh no, here it is. Here it is. So this is the log that they were talking about. Actually, yeah. And here's the second version of it. All right. So we played around with the pawn class. You don't need to play with the pawn class this week. I'm just showing it to you just so that you have an idea. Our purposes this week is to go to the level blueprint. We're going to go to here, and there is the open level blueprint. And this is an event graph that is specific to the level. All right. For our purposes, we need to put some things in the level. Stop. All right. So we need to put some things into the level in order to make this work. I am going to start with start with a cube. Here's shapes. There we go. Cube. And I'm going to go to the details. Should put this at 100. Yeah. Let's make this 0.1 high. Put it at 0. There we go. And I'm going to make this 2 by 2 wide, just so that it's a good. We'll go 3 by 3. You can click in here and move. There's a way you can click. You can adjust by moving your mouse. It's there. It's useful. Good to know when you do it by accident. But ultimately, it's not going to be not that graceful. I'm going to undo this. And I just want this 0.1 so that I've got, basically the purpose of this object right here is to know where my trigger is going to be. All right, triggers are invisible. So I'm going to put a platform here. Let's go to the content draw. Let's go to, make this bigger again. Here's materials. Get this up high. Again, I'm dealing with a one monitor situation. You could actually have your content folder off on another monitor, open another monitor. A lot of people, this engine is really built for 2 monitors in that regards. Can we pay attention because this is important. I'm going to use I'll use the concrete tiles. That's not, well, I'm going to undo that. I'm going to try this again. There we go. So I just want to get that with the concrete poured so that stands out. All right, next thing I'm going to go down to volumes. And there's all sorts of different volumes. We talked about the blocking volume. You can have a volume that blocks just cameras. Kill Z volume, if you fall through it, basically kills stuff when it falls out of the world. For our purpose right now, we're going to use a trigger volume. Where is it? Zero, zero, zero. There we go. Let's pull this over this way. And the big thing with the volume, brush settings. So right now it's set to be 200 by 200, 200. This was 100 by 100, so we can we could go and be like, hey, we can scale it up, or we can actually change it, the brush setting size here. So I'm actually going to do 300 by 300. So that will cover the whole thing. I'm going to do 400 right here, and then I'll move this up 200 units. And that will get us off the floor. You can see that this object is inside the trigger. The trigger volume right here, again, I'm going to, and the other thing I need to do is I do need to add a light for our purposes. To help us see that light, I'm going to go to the skylight. And there's basically settings here right now. So intensity, 3 lux. So we'll go over lighting settings right now. So this is right now using the lux standard for lighting. I'm going to do 0.5. I'm going to draw, and that will drop the light significantly. So it's a darker outside light. And that will help us, because what we want to do right now is then we can go here and add, we can place an actor, and I'm going to use a point light for our purposes. There are other different light styles. For our purposes, we're going to work with the point light. That's our basic lighting. That's our first light that you'll use in general. As you get further on and get familiar with the other light styles, like point light, there'll be spotlights and rectangle lights. For our purposes right now, this is the only light we really need to use. And I'm going to move this out a little bit, so yeah. I'll bring this up a little bit higher. There we go. So I don't get a hard specular on this object. And just so we know that this light is doing something, I'm going to make it a beautiful purple. And I'm going to do 16. I'll do 64 with the heck. All right. So you can see that the intensity right here has been set to a different style, candela. This is, again, so there is luminance, exposure value, lumens, and candelas. And then there's a unitless version if you, or old school Unreal. But I'm going to just use candelas right now. So this is what this light will look like when it's on. So let's go to, so the first thing that we want to do is when the level starts, let's turn this light off. So first of all, I need to have the light selected, and then I'm going to go to the lab blueprint. And I can right click and create a reference to the point light. And ideally, you want to work from the objects that object and variables that you want. If there's an operation on an object or a variable, go from there, because then you'll get context from that variable. And in this case, it's going to be we want to set visibility. We can go to the light point light component. Point light component is just basically a child of the light component. So I'm actually going to use set visibility. And the reason for this person... Oh, okay. And the big thing right here is there is so when you see red, these are Boolean. A Boolean variable is true or false. And so for our purposes, we want to make sure this is off. So this is a checkbox. Checkbox means it will be true. Without that, it'll be false. So that's the first thing we'll do is on begin play, we'll just turn off the light. Let's compile the level blueprint. We'll go back. We'll press play. And you can see, where's the platform? There's the platform. You can see the light is off. And I'm actually going to change the material on the platform. There is this, I'll get inside it. Use the hex pulse, what the heck. Have some fun. So that now stands out as glowy. So, all right. The next thing that we want to do is we want to go click on the trigger volume, because the next work we want to do. So basically, you're going to select something here, and then go to go in here. There is an event called tick. That happens every gameplay frame. So right now, we're not going to use tick for a while. We will eventually, but just know if you put something on tick, it will basically every gameplay frame. I'm just going to do a print. Literally, it will be the spam. And then we press play. You can see, oh, it's spamming because every frame it's doing that. So don't do this, is what I'm telling you. I'm actually going to delete this event. So these, you'll see begin play, tick, and then one of the collisions, particularly in the blueprint. You'll see those regularly given to you, grayed out. It's okay to delete them. You can, if I needed the tick again, I can go back and type tick, and here's the event tick. And you can see there's other ticks going on. So let's go back, make sure I do have the trigger volume selected. So I'm going to do a selection with, and one of the things you can do is you can copy and paste nodes, and I do want a second copy of this node. This is just more, I could do this off of one node, but it'll be cleaner to do it with two. So what I want here is an event. Again, this is going to be set. No, I don't want to use, sorry. I don't need references to the object. What I want is an event. There are events relative to add event for the trigger volume. And it's going to be under collision, and then it's going to be on actor begin overlap. And this will be, we'll do a print. So I'm just gonna see, hey, something is overlapping, and then I'll put in the event for the end overlap. So actor hit, basically this is think of collisions with solid objects. Given that we're a trigger, that hit's not going to be useful for our purposes. So I'm just gonna make sure that we got actor end overlap here as well, and then I'm just gonna go and I'm just gonna do a print. And I'll just do end overlap. And this is just so that again, I'm doing right here, making sure that we know something has overlapped and something has not overlapped it. So let's go back to Lab 02. We'll press play. Again, we're getting a start location. And then we can run over into here. You can see start overlap and overlap. So this is where I will grab this chain right here. I'll make this a little bit, give them a little more room. And I'm going to grab these three nodes. I'm going to copy and paste them. So one will go here. I can pull these down. And, feel free to get, grab, copy and paste. And then another one will go down here. So I will connect. So these are what's called the executive chains. So basically this is wired from here to here to here to here. Now these are pure functions, and they're basically, they calculate. So basically with this target here, it goes back through its chain and says, okay, get the point length, get its target location, apply that value here. It does it automatically, so you don't have to execute that and store it in a variable. That would be tedious. For end overlap, I do want this new visibility to be off. Again, here's the exec chain here that I want. So then we'll do, again, after printing start overlap, it'll go into set visibility. This will turn on. And there we go. This is basically what our lab is going to be like this week. I'll compile. Remember to compile. Make sure you save everything. Control-Shift-S. And we'll go back to the level, and you can see that I can run right for it. And I am now doing hello world. All right. So there's a functional level of stuff going on that for you to be aware about with Unreal, and then there's theoretical foundation pieces. I mean, for our purpose right now, we're all just playing with actor classes for the most part. We had an actor that was a trigger. We made a static mesh to be the platform so we could see where the trigger is effectively. Our player class is an actor, inherits from player controller. Let's go back over our slides right now. So I've gone over a lot of different pieces quickly. Pawn class. It's the base class of all actors that can be controlled by players or AI, and it can be controlled by an AI. So where we have a player state class, a player controller class, there's also an AI controller class. They inherit from a controller class, a generic controller class. The diagram you need to show me needs to show that player and AI inherit from controller. That's one of the things I'm going to be looking for, whether you're right or wrong with what you give me for an image. So, that's physical rotation. There's another version of pawn called character that's inherent off of it that basically has pre-built movement for an input system for characters. There's a vehicle version of it as well. So not character, but off a pawn, there's also vehicle. Don't worry about character and vehicle. Those are specialized subclasses. Get moving on. HUD class, we talked about all these pretty quickly. It's a class whose state withstands switching levels. So think of it as it's an instance of the state of the application. When you're running the application, there's an instance of this class. It's like game over player controller. There's so game mode and player controller are destroyed between level loads and resets. So if there's something application specific, you'd put this in the game instant class. Again, player name would end up in the game instant class, for example. Now that's if you're dealing with a single player scenario. So, any data you want to keep, like the player's health, ammo, overall score should be placed in the game instant class. So we can talk more about how that can be structured later on as we get deeper into things. All right. You can go through here. The exercise is not that important. You see, let's go over static meshes just briefly. Static meshes are the most common assets you'll use. And then in blueprint classes, you'll use static mesh components. But every level you'll make with static meshes. So there's two things you need to be aware about. There is the asset. So it's the core model. Think of it as the model, as defined out of like whatever editor it came from. Stores initial collision settings, stores initial material assignments for the mesh, LOD assignments. But then there's an actor version, and you can override information on the actor. So there can be many instances of the single asset. Like the level that you see consists of many different cubes. I can texture each of those cubes differently. And that's one of the properties that you can turn off. This cube has collision, this one doesn't. Those are actor level specific. So think of actors in a level are instances of assets. Have instances of assets, and you can change those assets on the fly. All right, moving on. So they have a pivot point that's local access. And this is going to be important next week when we talk about like objects, because you're going to build a doorway using multiple cube meshes. Two of the cubes that you're going to deal with will be actually the door you're dealing with. In case the vertices, edges, polygon. So the information look of the model, level of detail. So as you pull out, there are different. It swaps out different models for level of detail. So if you're further out, you don't need to render as much. It will look the same. Effectively, the idea is that we can use a simpler model to simplify things at distance. Collision halls, sockets. This is something that's relative to Unreal. UV layouts for textures and light maps and vertex color assignments. These are very specific things. Importing static meshes, FBX, OBJ are the two files right now that they are using. There is a third format that is growing. It's the GLTF. There's a 3D file format under the GLTF standard, and that's starting to be picked up by other engines are picking it up. So I wouldn't be surprised. I mean, this is an old slide. So this would be something that would have been added in the past 18 months if it's been added. So don't be surprised if there's another format. Again, this GLTF format is growing in popularity. So don't be surprised that you see that as one of the the 3D model version of that is growing in popularity right now. Why is it? OBJ is very old. No one really. It's. I don't know who. It's. The standard is out there and what it's supposed to, but it's not. It's been over a decade since it's been updated. FBX is an Autodesk format, and literally people are like, if they can get away from Autodesk, they'd be happy to. It's really kind of what's going on. Again, that's why that GLTF format is growing. Is because it's not. It's an open standard going forward. Importing static meshes, basically you can then add, again, you can open up the FBX import window. There are different, so when you import a FBX file, there's an import window that comes up with different options. You can bring in materials, you bring in textures, you can bring in, import as just skeletal. You can have it auto generate collision for the model. Again, you can go to the model itself and it'll open up the static mesh editor, which is another window. Let's actually go to one of the models and just show you that. So what they're talking about is they brought up the chair. If we double click on the chair, it brings up this window, which is essentially it's the static mesh properties that we can adjust. And it's really not, the big thing that I would probably be playing with might be materials. Now this has one material slot, so it has a material that's been defined for it. And you can use right click to move the camera around, WSD to move around like you're in free
free fly mode, no clip, and so I'm going to close this because I don't want to actually adjust anything. Yeah, we'll talk. It's not that we'll talk more about this later on, or like what those settings are. There's another class where we talk about assets, so we'll address it more in that class. But for your purpose right now, just know that you can set properties here. UV layout. So think of UV as how a 2D material is applied into 3D space on a model. And reserve the model needs UV let me out. I'm surprised that you can. Is it going to let you? I think it might let you adjust the UVs. Maybe that's kind of. I'll have to look at that later. We're not going to worry about UV and UV light channel. Again, this is more about specific about. This is art specific things. So I'm going to go over this briefly. There's like light map channels, used for storing light and shadow information on a surface mist. Basically, that's what that is. And I'm not going to go into detail. I'm going to let you read this because this is more art being pretty. Assigning a material to a static mesh asset. Again, here is the level of detail section, and there's this. Go back to as I go back to the editor. Again, right here is the material slots. Here's element 0, so this is the first element. And this is emp shear. This is, again, material for it. You've seen me switch materials on other things. In fact, I'm going to go back to the level itself. And next to this, I'm going to put in, there's a statue model that we'll use multiple times. Come on, why did it put in the level? There we go. And you can see that, hey, here's the static mesh. I'm going to copy and paste it, so that's a Control V, Control C. So I've got 2 instances of this mesh now. And you can barely see them because these are glass material. Let's click on this, and here's this material right here. And I can go to the content draw, and I can go to materials, and I can click and drag into there to set the material. The other way is I can literally go to, let me click on it again, click on this, and then I got it. This one I'm going to do gold. So I can type the material name and get it what I'm looking for. And I will click this one over here, and I'll make this one rust. Oh no, I'll make it steel. There we go. And I'll paste it one more time. And this one I'll do rust. And let me grab these. I'm just going to move them out of this zone right here. Again, put these over here. And then I'll just make a place actor, point light. There we go. So it'll just be in front of them. So there's attenuation radius. I'm going to do this 2,000. Not what I want. There we go. Make this 10. I'll go 8. I'll do 20. There we go. More what I want. So basically, I can go in. There are these lights over. Yeah, right over here. So again, this is the same static mesh, but each of these instances have a different material on that first slot. Again, if I go click on the model, there's also a second material. So there's the statue piece, and then there's the base piece. And for this one, I'm going to go. Let's do wood oak. You can see that I've now changed the material of that bottom piece. And let's do something funky. We'll do hex. What the heck? You can see there's that hex material that I've been enjoying playing with. So this is a version that doesn't pulse. So you can see that I've got now I've got 3 instances of the same model with different properties on it. So think of the asset has default properties set on it, but you can override those default properties in instances. That's the thing that I'm showing you here. And it's something that we'll do, why would I do something like this? Well, you can overwrite, like with a static mesh component in a blueprint, I could have 3 children of the same object and change what it looks like in each of the children based, for whatever were our needs. So they can be altered and changed in multiple different ways. So keep moving on. Collision halls. Basically, this is the collision of what it is. Typically, you'll if you don't create the collision hall yourself, then you will create have the engine create the collision hall for you. To get something set with. Okay. Couldn't turn some of the application. That's fine. We don't need this. We just need. We're dealing with a issue with Discord. Here we go. So we move on. And you can edit them. Again, this is an asset thing, so I'm just going over this just quickly. It's going about, these are per poly collision. Don't use this unless you know exactly what you're doing. So if you bring in a mesh that is cinematic level quality with tons and tons of faces and vertices, this will lag down the system very hard because it's got to track every point on one model to every point on the other model, and that could be millions and millions of calculations. So be careful about this with per poly collision. There's other ways you can do this. There's simpler ways to set up your collision. So static mesh actors. Again, this is basically placing them in the level. I've shown this a couple times. You can change its location, rotation. You can change its scale. You can say it's static or if it's movable. So if it's not something that's not going to move around, then make it static. We will have actors that will move around, so don't worry. You can change what static mesh it is outright. Like for example, let's go back to Unreal and show you. I'll grab this middle one right now. I could be like, I don't want this mesh. I want it to be. We'll just do the table round. And right now it's using the silver because that was the first material asset I assigned to it. Here we go. Here's the table round. Again, I could go and make it the text, hex stuff because why not? So I can change the mesh on the fly if I want what static mesh I'm using. I'm gonna save the level before we move on. Again, I'm going through this as quickly because again, a lot of this you'll go over in another class, so don't worry. Setting material assignment on static mesh. I've shown you that a couple times. Adding collision on a static mesh. So there is a physics system is what they're talking about here. So there's a collision section, and we can go and say, hey, let's go to the collision. Here is it. We can say, does it simulate physics? This is a physics object. Under collision, does it generate hit events? Does it generate overlap events? Let me make this bigger so we can see all that. Generate overlap events. So if we go over here to the trigger, you'll see that, where is it? It doesn't generate hit events, but it does generate overlap events. So things about, can the player step up on it? Actually, this would be a no. But there are presets. So right now, this is set to a trigger preset, and we can open this up, and we can see that it's set to ignore trace, visibility traces. It overlaps with the camera. What objects does it overlap with? World static, world dynamic, the pawn, physics bodies, vehicles, destructible. It will block soft collisions. Not sure why, but these are presets. So you will see there's a ton of them. Is it a pawn? Is it a spectator? Is it a ragdoll? Is it destructible? No collision, block all, overlap everything, block all dynamic objects. So pawns, for example, overlap or ignore only the pawns. Overlap only with pawns. So does it? Is it a pawn setting? Is it again? And so on and on and on. We'll talk more about collisions later on, and we'll be playing with this on a regular basis. And there's more than one place where we need to set settings, so just be mindful of that. So something might work because we have to set something somewhere else as well. This is the presets, collision enabled. Yeah, I just went over these. Okay. Basic blueprint. This is lecture 2. Let's do lecture 1. Okay. So again, it's a blueprint. Again, what is blueprint? It's a visual scripting system created by Epic that's been here since Unreal Engine 4. It's been upgraded a little bit since Unreal Engine 5. Some new features, more features, more modules. A script in Blueprint is represented by a graph of nodes connected by wires to define the flow of execution. So typically, they start from an event, and it flows from there. So input is an event. Begin play is an event. Tick is an event. The word blueprint can refer to a game object created using Blueprint. So blueprint, blueprint player controller, blueprint pawn means this is just a pawn that we've created using a blueprint class. Now, when we talk about classes in Unreal, it doesn't matter it's C++ class. It doesn't matter it's a blueprint class. A class is a class. A blueprint can inherit from a C++ class. It is, and it's still a class as far as Unreal is concerned in terms of entities. So we created we had again the pawn class that was created in the template that inherited off a character class that was defined in C++ code, and that inherits off of a character class. And that character class inherits off of pawn, which means it's also inherited off of actor. So that blueprint class is an actor class. That blueprint class is a pawn class. So any reference of pawn, we can put a reference of our character in there. Now we can be very specific. We can be hey, we only want references of the blueprint class.
So any instances of the blueprint class that have been spawned in the world or put in the world, we can access.
Again, we talk about level blueprint. Again, this interacts with blueprint level specific things, and then there's blueprint classes. Think of entities. Use level blueprint sparingly for very specific level specific needs. The blueprint class is for generic. For those who are coming from Unity, it's your equivalent to the prefab. Typically, blueprint classes is what finishes off other classes, the parent classes. So we create a weapon. There will be a blueprint class that finishes off that weapon class that we'll actually use. So the rocket launcher actually has a blueprint class now that defines the finest, what model it's using, what material, and whatnot for that class. Object, actor component classes. So object, base class for all object Unreal. All our objects are subclasses of the object class. Think of this as the kitchen sink for generic things in Unreal. Actor class is the base for objects that can be placed and spawned into the level. 90% of your classes that you're going to build will inherit from actor in some way, and maybe through, and this can be through other inheritance. So again, pawn, character, through inheritance, inherit actor. Actor component are base components that find reusable pieces that can be added to actors. So while there is a static mesh actor, in Blueprint there will be a static mesh component, and they're different. And I understand that the static mesh component is a component of an actor class. So next week we'll build a blueprint class that we'll put in, and it'll be the whole shebang. There'll be a light component. There'll be a volume component. There'll be a static mesh component. Whereas they are different actors in the level right now in the level that we're using. So. Moving on. Instance of class, again, references to instances of object of a class. Think of so when we talk about a class, think like the term blueprint, like we have a blueprint for a car, or blueprint for a building. We can build the same building 3 times. This one's red, this one's green, this one's blue. In this case, they've got an image here of 4 different chairs. And the difference between these chairs right now is basically they are all in different places in the world. We could, again, go in and make different material changes. Now, if this was built better and with two material IDs, we could have one for the metal of the chair, and then whatever the seat is, we swap out different materials easily. Unfortunately, it's just one material right now for our purpose. But you'll see that's very common. That we'll set up a mesh with multiple material IDs on it, and that's something you'll learn in another class, unfortunately. But I'm just going to tell you that instance. Again, 4 instances of the chair, of the blueprint chair, have been added to the scene. They're in different locations, and that's the difference between them right now. We could rotate one. We can turn one, turn it around. That's a different change on the instance of that actor. So we can create a blueprint class. Let me go actually show you in Unreal because it's slightly changed. Let's go to our level 2, and we can go right to, and there is blueprint class. So it has slightly changed from UE4 to UE5. And it will ask, and this is slightly changed as well. It's not, these are now more grayer. But basically, it'll ask what the parent class is. And it's going to show you these classes by default. In fact, let's actually go show you. We can right click, and I'll click blueprint class. Here's that window. So it's slightly changed. Is it an actor class, pawn class, character, player controller, game mode base, actor component, scene component? if you're not looking for something here, and we will get, a good example is, hey, the HUD class. There is a there is widget component is another one that you'll deal later on. So if you're looking for a very specific class, then you'll go into all classes down here and use this to figure it out. I'm not going to actually create it because I just want to keep moving on. Creating blueprint classes, actors in the level. I mean, again, you drag them into the level and you work with them. We'll worry about this later on. Basically, this is going to go over. There's the toolbar, components panel, my blueprint panel. This is the blueprint editor. So I'll go over this again next week. Yeah, I'll go over this next week. Again, you can right-click anywhere to bring up this event. Again, let's bring up what we're talking about is that you can right-click anywhere and get this action for this blueprint. And again, because I have the trigger volume selected, I can do things relative to what it is. If I need to switch to a different object, again, this is literally go click on the point light, go back, and I can right-click, and now I can do actions based on that object. So this is context. This will have the same level of context in a blueprint class as well. There's a different version of this in the blueprint class. I'll show that off next week when we go over that specifically. Let me just make sure we talked about that. There we go. Placing modes. No spin wires. I showed you right now. Here's begin play. We can set a value. One of the things that we can do is that we can create variables. So I'm in this level, so I can set a variable here. I'm just going to say this is. I'm just going to call it number for the sake of argument, and I can make and this is how I can change the type. Is it a Boolean? Is it a byte, 8-bit number? An integer 64 bits, float, so anything that has a decimal point. Name string text. So text and name are Unreal variants of the string. Vector it's a 3D vector, has an XYZ rotator. It's a 3D rotation, so it has. I think it's a version of the Quaternion class that's specific to Unreal. The Quaternion class you'll see is typically how they're used to store rotations. Unreal Engine was developed and established before we realized Quaternion was the best way to manage our 3D rotations. That's how old this engine is. The original rotator class had 3 values, an X, Y, and Z, and they were an integer. And there was a chart that we used to use that basically 0 to this was 0 to 90, this was 90 to 180. They were using integer math to do their rotations, not flotation math. And it's because when we go back to the late 90s, doing those float math calculations were very expensive, significantly expensive. And so the processors just weren't powerful enough to do them on the fly. So they did, for an optimization, they decided to do integer math. That has now changed. They are actually using the Quaternion underneath the hood, but the class of rotator still remains because it's the heritage of the engine, effectively. Transform basically is a structure that holds the position, the rotation, and scale of an object. So it's a structure that holds 3 other structures. And we've seen that already. I'm going to just go and make an integer. and I'm going to compile. And once I compile it, I can now set a default value down here. Hooray, 10. And I can go in and I can drag this out and I can get it. I can also set it. I'm going to delete this right now. Oh, I deleted the wrong thing. And then off of, so basically, here's my event begin play. I can go and basically set the number. Now, what's nice is I can set it by I can calculate a value. I off the set, I can also grab it. So I can do a print, and I will just drag that in, and it'll do. And in this node, basically right here is added for me and this is basically taking the node and it's transforming it from a number into an actual string to be printed out. And if I compile it, I run my level, you can see 9001. Hooray. For those who want to be accurate about it, the error number was actually 8001. But anyways, again, anytime I make a change on the graph, I will need to recompile. So make sure you recompile. Make sure you're saving everything. Save often. Get in the habit of using Control-Shift-S on a regular basis because we're making a change to the level graph, which is a part of the level. So both of these have to be saved. So rather than saving one thing, save everything. Save it often. Good time. Yeah, we will talk more about things next week with Blueprint. Again, this is Hello World. I mean, I could have done both of these. You know, I could have chained this down to here. I don't do that specifically. I'd rather do copy the chain and do it because it looks nicer in a graph sense. And I'm OCD or CDO, for those who are of that persuasion, about making things in order, making things. I don't like what I'm trying to do is don't cross the stream is what I'm saying. You know, this is effectively doing the same thing. I can right click and I can break connection, break link to, break it as well, break this link, then I can establish this one. But let's go back. What I don't want is I don't want to be crossing these wires because it makes it harder to see and understand. There will be times where you will have to. And then there'll be things that I'll be doing later on. Let me put this back. But ultimately, I would prefer you do this because it's cleaner. I think one of the things that I will show you that there is functions and macros. Yeah, I'll talk about those next week. Or about function and macros next week. So if there was a common piece of code that you want to use over and over, make a function. If you've got a piece of something that's like 5 or 6 modules long. If this was any longer, I would be making functions to do smaller, to break this down into smaller things. We'll talk more about, but so for that reason, I'm actually very function heavy in how I go about things because I'm basically isolating. The idea is I'm isolating pieces of code so I can reuse it. And also, by isolating the code, I can also make a chain much easier to read. Distinct action, which are functions. And that makes, my tick needs to do this, and that. And these actions have like 10 different modules and wiring for each individually. Well, if I, again, isolate that code into the functions, I can put down one node that does everything I needed to do. And I'm just going to point that out. Again, you can go here and just create, we'll talk about what an override is later on, but basically if we put a plus button right here, we'll just say this is new func, And I can take the number, actually, let me rename this. Add to number. And one of the things I can do is I can, get it. One of the things I can do is I can add inputs. So I can add we'll just call this add to, and I'll make that an integer. We'll come over here. There's other types, arrays, setup, maps, sets and maps. We'll talk about these three in another lecture later on. Right now, we're using single values right now. So now this function now, basically when I call this function, again, the idea is that I can grab the number, I can set it, and I'm going to use the plus sign to bring, do math. So I'll add these together, and the result is this pin right here, which I'll put here. And then I'll just link this executive until when this gets called, this node gets called first, this number looks back, grabs this value, grabs this value. This is the value that will be passed to the function. Conversely, we can have an output. And we'll just, for the sake of our, we'll call it new number. Now, this is redundant because I am signing it to that value, but this is just the sake of argument. Hey, I'm going to plug this out here. So when I'm done with the node, so let's compile. When I go back to the event graph, I can now drag out this function. I can add whatever value, and whatever that node number is going to come out on the other side. So this is just showing you, we'll go over functions in more detail. There's actually other functions. There's things that we can do to the function to, we'll go over functions in more detail in another assignment. But I just want to show you, hey, here's a function. Macros are pretty much the same thing, except they're just not callable from outside of the, so other classes can't call the function effectively. Only this class can call a macro, which is why I don't use macros. I prefer the function instead. Yeah, typically if you're not sure whether to use a function or a macro, use a function. There'll be more function. You'll have more functionality related to the function if you go that way. Anything that I've gone over, I've thrown a lot at you really quickly, really fast, or any questions? Are you all deers in here deers in the headlight right now at the moment?
Oh, I've been hit already.
What was that?
I've been hit already.
Oh, okay. So we're past deer in headlight. We are truck has hit deer.
My eyeball is in the grill right now.
Okay.
Truck has hit deer. Deer still processing headlights.
Yeah. Who is truck has backed up over deer again? Okay. It's okay. Is this your first time doing programming?
I don't even know that much about computers.
That would be a yes. So this is your first time using Unreal. This is your first time doing programming. This is all new to you. Take a deep breath. It's new to you. It's okay that you don't understand right away. We'll go over this, and I will go over this again multiple times during the lab. I will probably go over this 2 to 3 times this Thursday with you, so don't feel bad. Several of you are going to go, it's going to go out one ear and out the other, go in one ear and out the other right away. And that's okay. We will go over this multiple times. We'll go over, practice this. We'll do some variations on stuff so that you understand what's going on. And I'll go over variants. There's things that we can do, other things that we can do. You will find there is more than one way to do something in this engine. There's options, and we'll talk about those as we go along. There'll be one option I'll talk about on Thursday specifically.
Okay, so for the labs, is this something that we're going to do in class, or is this something?
Yeah, Thursday you're going to do in class.
Okay, I thought it had to be done already by that day.
No. So let me go back. Here's the module for this week. This is the quiz that I'm asking you to do, And this is the lab. Let me just look at the quiz one more time. Make sure. Yeah, okay. There's a single question for the quiz. But this is the lab. Make up canvas. There we go. You are going to provide me a screenshot of your level blueprint. That's how I know you did it. This is the assignment is not turned in. You'll demonstrate to your instructor in the class lab and then provide a screenshot. Again, let's go back to Unreal. I mean, we go back to the level itself. I mean, we did this. This is the assignment. And I'm showing you the answer this way so that you can follow the process, so that you can work on this. So you can go by step by step. The one thing that's not really necessary, but it's here for convenience, is the platform. And that's there so we know where it is. Because if I take that away, start looking around, I'm not going to know which of these is the right pillar to go run towards. Yeah. And this is a practice I'm telling you to do this is something as a level designer I had to learn to do when I was working on things. Why? Because the trigger is invisible. Because if I didn't put that there, I didn't know where the freaking trigger was. And this is common whether you're in something off the Quake branch, off of Half-Life or Call of Duty, or here on Unreal, or something in Unity. Doesn't matter what engine you're in. If you don't put something visible for your trigger, you won't know where your trigger is. Bottom line. And this is the 3D version of it. There's variants of this in 2D. Put different tiles down. Put down different tiles where the trigger is, so you know. Again, that's the 2D version of this. So don't. Yeah, and this is a level design technique that I'm showing you that will make your life easier.
Is the trigger for it could just generate any sort of response that you assign to it?
There are many things. Yes, the trigger can do many things.
Okay, in that case, I think I've.
This is the functionality here is player enters a zone.
Mm-hmm.
And I'm calling a trigger here in Unreal. They're called volumes, but it's an area, a volume, a trigger that they enter into, and that because they overlap, there is scripting associated to it to do something. Mm-hmm. There's an event, basically overlap. Player entered. And again, this could be named very different engines. Player entered. Player left trigger. This is overlap. Did not overlap. I know in Unity with their triggers, you can actually track when the player is still inside the trigger. There's an event for that as well. You will hear about that in 3 weeks, probably 2 to 3 weeks on that other class, so don't worry about it. But here with Unreal, there is actor overlap, begin overlap, and actor end overlap. Those are the two events that we're concerned about.
I've definitely played games where it was hidden on purpose because it was being mean to me.
Oh, well, it's not that it's... Again, triggers by definition. Again, when we hit G, if I go into here and I hit G, that's my game view. So right now, this is the game view with the light on. Now, obviously, I can go, one of the things, again, when I go press play, I don't have that light on because it's turned off by default. Again, if I was looking this way, if the trigger was like, let's say I didn't have that, like which one of these would have been the thing I would have needed to run to if I didn't have that platform. Again, that's the purpose of the platform. Something I just noticed is that this material has what's called emission. So materials can emit light, little bits of light. And this is actually, you can see that it's actually emitting some light. It's emissive light off, and you can see it on this cylinder right here as it cycles through the colors. So materials are pretty powerful now here. What would we use an emissive for? A monitor that had monitors that I wanted to have some light off those monitors, but I didn't want to play with a point light to generate that light.
That would be one way to use emissive. So we'll talk more about materials and all the things that you can do and what you shouldn't do. We'll build some bad materials at some point. Hooray! Yeah, yeah. There's things, and just again, particularly both Epic and Unity have a material system, but there's also what's called GLT. There's the GLTF standard, which is a standard for building materials. So, I talked about it a couple times. There's from materials. There's what's called shaders, which can do a lot more than we'll get into all of this in due time. So just don't worry. Any other questions? All right, I'm going to stop the recording right here.